Many people believe that the low carbon energy transition cannot cause severe environmental issues. But is that true? Is the risk for severe environmental issues really low for the energy transition? Welcome to Key Facts about the journey to our future energy system. I'm your host, Tushar. I have over 25 years of R&D experience in addressing environmental issues in the energy field. This includes technology evaluation, development, and commercialization. In this episode, we will use lessons from historical data and basic science to review the environmental risk from the energy transition. First, let us consider the learnings from historical data. Past data has taught us that the true environmental impact of a technology is not obvious at low levels of use. The true impact is only recognized after the technology use reaches a minimum level. This minimum level of use is required to obtain robust evidence of the true impact. Let us look at a few examples. Chlorofluorocarbon or CFC technology was developed in the 1920s for the refrigerant industry. CFC technology solved serious health and safety issues related to the technology that it replaced. Because of its benefits, media described CFCs as a miracle technology back then. The CFC technology was used across the globe for a long time before its true environmental impact was identified. Its true impact, that is, loss of ozone in the stratosphere and the resulting impact on our biosphere, was only recognized after several decades. It took 5 decades for the CFC technology use to reach the minimum level required to obtain robust evidence about its impact. A global agreement was finalized in the year 1987 to phase out CFC technology. Plastics technology is another example. The modern plastics technology was invented in the early 1900s. The annual use of plastics increased from 2 million tons in the 1950s to over 400 million tons in recent years. The severe impact of plastics on the environment only became clear in the recent decades after a massive rise in its use. Most plastics are disposed in landfills, dumps, or in the environment after their use. The massive disposal of used plastics has caused severe impacts. Examples of the type of impacts are blockage of waterways and harmful impact to the ocean ecosystem, clogging of sewers, blocking of airways and stomachs of hundreds of species, transfer of toxic materials to humans via the food chain, and release of harmful gases during disposal of plastic waste. As in the previous example, the side effects of plastics were not fully recognized until a minimum level of use was reached. The use of palm oil as a fuel is the third example we'll discuss. In the early 2000s, the European Parliament encouraged the use of vegetable oils such as palm oil to decrease the use of fossil fuels. This resulted in a large increase in the demand for palm oil. Producing countries such as Indonesia increased their palm oil crop in response. The impact of this action became clear only after a decade of accelerated use of palm oil, that is, after the minimum level of use was reached. The impact was substantial: deforestation, biodiversity loss, and a net increase in greenhouse gas emissions. The European Parliament took corrective actions based on these findings in 2017. What about the impact from fossil fuels? The most severe impact from fossil fuels is the impact from climate change. But the severity of this impact was recognized only after a supermassive use of fossil fuels. Use of fossil fuels began in the 1750s. It took a long time to establish the link between fossil fuels and severe climate impact. Arrhenius in the early 1900s and Callendar a few decades later were the first to link fossil fuels to the warming of Earth. Interestingly, both believed that the warming would be beneficial in the long term. Yes, you heard it right. The pioneers who first connected fossil fuels to global warming believed that it would have a positive impact. Obviously, the scientific society did not have concerns about the climate impact of fossil fuels back then. A significant concern about the climate impact emerged only in the early 1970s after the minimum level of fossil fuel use was reached. Why was the potential for a serious climate impact not recognized earlier? because the required data to recognize the true impact was not available at low levels of fossil fuel use. Thus, from historical data, we know that the true environmental impact can only be recognized when the technology use reaches a minimum level. This has important implications for the low carbon energy transition. Solar and wind power and the other popular low carbon technologies are used at very low levels currently. For example, solar and wind power provide only about 5% of the global energy. Electric cars currently represent less than 4% of the total global cars. Solar and wind power are crucial components of the low carbon transition. The current level of solar and wind power use is very low. Specifically, it is several times lower than the level of use at which a significant concern emerged for fossil fuels. So, how low is the current use of solar and wind power relative to the historical use of fossil fuels? It is even lower than the use of fossil fuels when their climate impact was believed to be beneficial. Recall, Arrhenius and Callendar were the first to propose that the use of fossil fuels would warm Earth, but both believed that the warming impact of fossil fuels would be beneficial in the long term. Callendar discussed his beliefs about the beneficial impact in the late 1930s. At that time, the global fossil fuel use was already substantial. In fact, fossil fuels produced more energy in the 1930s than that produced by solar and wind power combined today. This is very revealing. The warming impact of fossil fuels was speculated to be beneficial even at a level of use that is higher than the current use of solar and wind power. This tells us that the current use of solar and wind power is far below the minimum level at which their true environmental impact can be recognized. Currently, solar and wind power provide about 4,000 terawatt hours of electricity. This needs to increase by a multiple of 15 according to the International Energy Agency and other net zero proposals. So, will solar and wind power have a severe environmental impact when there is a massive increase in their use? Basic science tells us that the answer is a very likely yes. I will discuss the basic science aspect briefly. Fossil fuel power, solar power, and wind power have the same primary source, that is, solar energy. Solar energy has two major challenges from the viewpoint of meeting our round the clock energy demand. It is dilute and intermittent. Nature has eliminated the diluteness and intermittency challenge in case of fossil fuels. Over millions of years, nature has transformed the solar energy captured by organisms to fossil fuels which have high energy density and are available 24 into 7 for energy production. Meeting our 24 into 7 electricity demand is much easier for fossil fuel power because of this massive help from nature. Solar and wind power do not receive such help from nature. They must deal with both the diluteness and the intermittency challenge of the energy source. The task of providing 24 into 7 electricity is therefore far more difficult for solar and wind power. The implications are obvious. This means that the resource intensity is far higher for solar and wind power. I have discussed the details in an earlier episode. The risk for environmental impact is related to the resource intensity of the technology. Resource intensity tells us about the total resources that will be required. Example of resources are critical minerals, steel, cement, other materials, land, energy, and water. The use of any of these resources has a certain impact on the environment. For example, consider the impact of mining or clearing land on the environment. A high resource intensity equals to a high risk for environmental impact. The shift to low carbon power will require an extraordinary increase in solar and wind power. It will also require a massive increase in energy storage technologies and vast electrical networks. Solar and wind power have a much higher resource intensity than fossil fuels to produce 24 into 7 electricity. So low carbon power, when used at levels comparable to fossil fuel power, will have a very high resource intensity. This is true for most low carbon energy options. Low carbon energy options require several times more critical minerals and bulk materials compared to conventional options. Overall, a shift to low carbon energy will require a massive increase in the use of critical minerals, land, cement, steel, and other materials. This suggests a high risk for a severe environmental impact. Let us use critical minerals as an example. Critical minerals are far more difficult to extract and process compared to common metals. A high level of difficulty to extract and process means a high risk of impact on the environment. The known impacts related to the extraction and processing of critical minerals are soil erosion and contamination, biodiversity loss, water contamination, reduced storage capacity for surface water, hazardous waste, and air pollution from fine particles. Practical issues are likely to make it worse. A rapid shift to low carbon energy will create an intense pressure to speed up the production of critical minerals. Health, safety, and the environment are likely to be compromised to decrease the cost and increase the speed of the output at many locations. This will markedly increase the risk of severe environmental impacts. I use critical minerals just as an example. The other resources required for low carbon energy technologies also have an environmental impact. The severity of this impact or the true impact will only be recognized when the low carbon energy technologies reach a minimum level of use. Some final comments. Nature has provided a massive helping hand to fossil fuels to provide on demand energy. The popular low carbon energy options do not have this benefit. Consequently, the resource intensity for the low carbon options is markedly higher than that for fossil fuels. A high resource intensity indicates a high level of resource requirements per unit of energy produced. When low carbon options are used in comparable amounts as fossil fuels, they'll require supermassive amounts of resources. This is an indicator of a high risk for severe environmental impact. I'll discuss a path to lower this risk in the next episode.